pre-algebra people. We are here today to talk about the area of circles. So far in lesson 10.1 and 10.2, we've talked about the area of parallelograms, triangles, and also trapezoids. But now we have a new shape to discuss, circles. Alright, let's go ahead and start with a little recap of what we learned before. Let's go ahead and start by recapping what the area of a rectangle is. Here we have a rectangle. Now if I went ahead and shade it in the inside section, because whenever we're trying to find area, we're trying to find all the space on the inside. The formula that we learned for a rectangle, for the area of a rectangle, is base times height, where the base is going to be the distance running along here, and the height would be this section here. So the base times the height would give you the area, and remember, the area is square area. Now next we talked about a triangle. A triangle can be made by just taking a regular rectangle and cutting it in half by drawing a diagonal. Okay? Now if we wanted to find the area of a triangle, we can do something very similar to what we did before. What we can do is we can shade half of this rectangle, and if the area of a rectangle is base times height, and a triangle is just half of a rectangle, it's base times height divided by 2. So the area for a triangle would be base times height divided by 2. Now this was a triangle. Now we have the circle, and we have a few problems with the circle because there's no real base. I can't really tell you where is the bottom of this thing, and there's no base where we can figure this thing out. Alright, now the height, maybe we might say it's a diameter, but this is a little bit of a different shape, so we can't use the same thing that we've used before. We're going to go ahead and use the help of this polygon generator to kind of figure out, well, what exactly is a circle? Because some people would say that a circle is just a shape that has no sides, while others might argue that a circle is a polygon that has infinite amount of sides. Because if you take this triangle, the triangle is the smallest amount of sides that a polygon can possibly have. And if I said n is the number of sides and I increase the sides, every time that I add a side length, you can see that the shape becomes a little bit closer to a circle. Alright, just kind of increasing. You can say that the more sides that you add, the more circular it becomes. In fact, your book does a really good job indicating this. If I took a piece of paper, a circular piece of paper, and I started cutting it out into these little wedges, these little triangular wedges, and I lined them up like this, and I kind of had one pointing down, one pointing up, one pointing down side by side, I would actually form what looks very similar to a parallelogram, where this bottom part right here would be a base, and the height would be the distance from the base that's perpendicular to the top. That's kind of interesting. Your book kind of goes through a little bit of math and kind of shows how this is true, and they arrive at a new formula for you, kind of pointing out that the fact that if the base is just 1/2 of the circumference of a circle, then times the height, which would be the radius, we have a brand new equation for you. And this is the key equation for this entire lesson, the area of a circle. The area of a circle is pi times r squared. So if we will go ahead and go back to our shapes that we talked about so far, a rectangle has the area of a base times height. The triangle is base times height divided by 2. And let's go ahead and look at a circle. The circle is going to have a new formula for us that we just talked about. We have the area is equal to pi r squared, where r represents the radius, the distance from the center of the circle to the outside, and pi is approximated using 3.14. Because you can use calculators on your lesson, it shouldn't be that difficult just to plug this in and multiply. you would, on a calculator, you'd multiply the radius times itself first, and then, like in life, you save pi for the end, you save the pi for dessert, and you multiply it by 3.14 once you finished. Let's go ahead and look at example 1 now. Find the exact area of a circle with a diameter of 12 centimeters squared. Now, a couple of key things. First off, they want the exact area. So what that means is they want you to leave your answer in terms of pi. We'll go ahead and finish. We'll show you. I'll show you that soon. Next thing I want to know is that they give us a diameter. We just learned that the area of a circle is equal to pi times radius squared. But we have a diameter of 12 centimeters. So, if you guys remember, the diameter is a distance all the way across, and the radius is halfway across the circle. So that means the radius is just going to be 12 divided by 2, which is 6 centimeters. So, the area is equal to pi r squared, which is equal to pi times 6 squared, which is equal to pi times 36. And we're just going to leave this as our answer, 36 pi. And our units would be centimeters squared, because area is squarea. Now notice I left my answer 36 pi, and I did this because they want an exact answer. If I use 3.14, that's an approximation. If I substitute 3.14 for pi in this case and multiply it, that's an approximation. That's not an exact answer because we're rounding pi to 3.14. Instead, when they say an exact answer, they want to leave it in terms of pi. There should be a pi left in your answer. Let's go back and check our book. Hey, look at that. They got the same exact thing as us, 36 pi centimeters squared. All right, let's go ahead and look at California Standards Check number 1. Let's go ahead and switch to this guy right here. All right. It says find the exact area of a circle with a radius of 50 inches. So our formula, we're just going to write it down, and something I encourage you guys to do whenever you're solving problems like this is to write the formula down first. That's step number 1. Step number 2, we check to make sure all of our numbers that we can substitute would match. Like in this case, we need the radius, and they give us the radius, so everything checks out. Now we can go ahead and say this is the same thing as pi times 50 inches squared. 50 inches times 50 inches is the same thing as 2,500, because 50 times 50 would be 2,500 inches squared. And if we go ahead and put this in the correct order, we usually want our numerical values in the front. And we say pi for dessert, we put it in the back. And our answer should be 2,500 pi inches squared, because area is squarea. Example 2 now talks about estimating the area of a circle. And when they say estimating the area of a circle, what they want you to do is to use 3.14 for pi. The size of a mountain lion's territory depends on how much food is available. Where there is plenty of food, the circular territory of a mountain lion may be as small as 5 miles in diameter. Find the area of such a region to the nearest square mile. So again, we're trying to find the area of a circle. So pi times r squared would be the area. In this case, they give us a diameter, so 5 divided by 2 is 2.5. 2.5 times 2.5 is 6.25, and we would have pi if we found our exact area. But they want us to go ahead and estimate it and round to the nearest square mile. So one extra step, instead of just leaving it in terms of pi, we're going to multiply 3.14 times 6.25, because we can use calculators in this chapter, and we find out it's 19.625. The last part of the question says find the area to the nearest square mile. So they want you to round to the nearest whole number. 19.625. Is that closer to 19 or closer to 20? Yes, very good. Very good. It's closer to 20. So the correct answer would be 20 square miles. This predatory cat right here would have an area of about 20 square miles that he would use to hunt. All right, cool. All right, standards check number 2 says find the approximate area. So it's no longer exact, so we know we're going to estimate by using pi is the same thing as 3.14. Find the approximate area of a circle with a radius of 6 miles. So we're going to go ahead and just say pi times 6 squared, because they give us a radius in this problem, is going to be pi times 36. 36 times pi, or 3.14, would give us our answer. So we're just going to type this on a calculator. 36 times 3.14 says 113.04 square miles. Now, that would be a good enough answer. On your homework, they're going to ask you to round to the nearest unit, so this would just round to about 113 square miles, because 113.04 is closer to 113 than 100. The last thing we're going to talk about this lesson is how to find the area of an irregular figure. An irregular figure is more than just a rectangle or a triangle or a circle. It's just kind of using our critical thinking skills to figure out, okay, well, what is the area of this? Now look at this shape. It says a pound of grass seed covers approximately 675 square feet. All right, looking at this problem, we want to figure out, well, how much square feet is there in this shape? It looks like we have a rectangle and a half of a circle. So what we can do is we can find the area of this shape by finding the area of the rectangle first, and then the area of the half circle. Okay, so here we have our figure of the area that we're trying to find. All right, we have a rectangle on the top. The formula for the area of a rectangle is base times height. So 45 is the base, and the height is 25 equals 1125 square feet. That one's pretty easy. Now this isn't a circle, it is a half circle. So when the normal formula is pi r squared, now we have to divide it by 2 because we're trying to figure out what's half of that. If I plug in my radius is going to be half of 30, which is 15. 15 squared is 225 times 3.14 substituted in for pi divided by 2 gives us 353.25 square feet. The total area is going to be the area of the rectangle plus the area of the circle, which is about 1,478.25 square feet. All right, cool. That's good to know. Now the question is asking how many bags of seed would they need if a one bag covers 675 square feet. What you do is you would then divide it by 675, and you'd figure you need about 2.19 bags, right? It doesn't make sense to buy 0.19 or that's how many pounds you would need, right? So you would buy one 3-pound bag of seed based off this question. Now, part 3 would be done very similarly. You'd find the area of the rectangle, and then you would subtract the half circle because they don't want this part. It's like they took a bite out of this section. So for your homework, you might have a couple of questions where you either have to add a shape or subtract a shape. In this case, you would subtract. All right, that's it for this lesson. I hope you enjoyed it. I hope you paid attention. I hope you watched this before you started your homework. All right, good luck, guys.